Welcome to Mod 7. In this unit 1 of Mod 7, we're going to attack the process of factoring polynomials. Now, you've been working in polynomials in a previous course in Chapter 5, which would have been Mod 6 from the previous course. Now we're going to work with these polynomials and we're going to factor them. Now, just as a little bit of review for factoring, if I ask you to factor the number 12, now it depends on what I say about factoring, but usually I talk about with prime factors, meaning that it can't be broken down any further. Now, what I'm going to do with the number 12 is not what I'm going to do with my polynomials, but I want to make sure that you understand just what the concept of factoring is. It means find the prime factors, those factors that can be broken down no further. 2 times 2 times 3, those are the prime factors of 12. I'm not going back over and talk about how you get them, maybe using a factor tree, but this is the prime factorization of 12. To find factors means you're finding those quantities that can be multiplied together to give you the original. By them being prime factors, they can't be broken any further. That's what we're going to do with polynomials. So let's take a look at our first ones. We're going to have different techniques to use. The first technique we're going to use is greatest common factor. Now I want to take a minute to have you take a look at this flow chart. If you're looking at this video with it very small, then you might want to enlarge it to full screen size. This is the factoring flow chart. I'll come back to it periodically. It says if you're going to factor a polynomial, at the top, this is where you start, you're going to look for a GCF. If there is a common factor, factor it out. We'll come back to this, but greatest common factor. You're going to look at your polynomial and you're going to see if there's a common factor. This method is the reverse of the distributive property. And I hope you remember that if you had, say, 2x squared and you multiplied it by x to the third minus 4x squared minus 7x plus 2, and you use the distributive property, 2x squared times x to the third, you would use the product rule, add the exponents for 2x to the fifth. 2x squared times negative 4x squared, that'll be negative 8. Use that product rule that says add the exponents, so x to the fourth. Positive 2x squared times negative 7x is negative 14x to the 2 plus implied 1 is 3. And then finally, my little arrows are very messy, 2x squared times 2 is 4x squared. In this lesson, we're going to take polynomials like this, try to discover what was distributed, and yank it back out. It will feel like we're dividing. Let's look at problem number 1. We have 3x plus 24. First, I look at the numerical coefficients, the numbers. Is there anything that goes into 3 and 24? The answer is yes, 3. That is your common factor that's a number. Is there a common x? No. Then the only common factor is 3. Now, to see what you would have if you factor it out, factoring it out is like dividing. You can show this or not show this, but this is what you're doing. 3 goes into 3x, x times. 3 goes into 24 plus 8. You have factored that polynomial by factoring out the greatest, the very largest common factor that you can. All right, let's look at the next one. Factor out the GCF. I have x to the 8th, I'll write it down, plus 4x to the 7th. First I look at the coefficients. Because this one has an implied 1, there is no common factor that's a number. I look at the variables. I have x to the 8th and x to the 7th, so yes, x is in common. I can take out no more than the lowest power, and you're going to want to remember that. It's the greatest factor you can take out, but it is the lowest power. So once again, I'm going to divide by that common factor that I have determined. And this time, because I'm dividing, I use the quotient rule. X to the 8th over x to the 7th is x to the 8 minus 7, which is implied 1. You would not write the 1. Plus, this x to the 7th divides out with that x to the 7th, and you have 4. If you factor this original polynomial, take out the greatest common factor, you're undoing the distributive property. Let's look at number 3. Factor out the GCF. I have 8y to the 4th plus 4y to the 2nd. Look first for the common factor. What will go into both 8 and 4? If you answer 2, you're right, it does go into them, but it's not as large as it can be. What else? You could actually take out 4. So if I factor out a 4, now I look, do they both have y's? Yes. What power of y can I take? I can take no more than the low one. So I put y to the 2nd. To determine the rest of the other factor, it's as if I am dividing by that common factor. 4 goes into 8 2 times, and y squared goes into y to the 4th. I subtract the exponents. 4 minus 2 is 2. For the second term, it's going to be positive. The 4's divide out. The y squareds divide out. Now you notice I didn't say cancel out. I said divide out. And when you divide out those, although we don't always remember to write them, it leaves little ones behind. That is 1. If you don't put the 1, then if you checked it with distributive property, there would be no way to ever get this term back. You can check this by using the distributive property. Let's look at a couple more. I have 18x to the 3rd plus 8x squared plus 14x. Is there a number that goes into 18, 8, and 14? Yes, 2, and that's the largest. Do they all have x's? Yes. I can take no more than just x. Remember, it's always the low power of the variable is the most you can take. So divide them each by 2x, and that will give you 2 goes into 18 9 times, so I'll put a 9. With the x's, there's an implied 1 there. Use the quotient rule, subtract. 3 minus 1 is 2. For the next one, 2 goes into 8 4 times. Subtract the exponents. I have x to the implied first power. Don't put the 1 though. Then 2 goes into 14 7 times. And the x's divide out, so I'm done. A common mistake that I see sometimes is that when students write down the factors, they neglect to put the greatest common factor out in front. You have to have 2x, parentheses, the whole thing. You have to have all of it. All right? Number 5. This is really going to challenge us and see if we can keep up with our exponents okay. We have a to the 6th, b to the 8th, minus a to the 5th, b to the 4th, plus a to the 4th, b to the 7th, minus a to the 4th, b to the 4th. I hope I have enough room to do this. Common factor. Well, there's no numerical coefficients written, so I look at my variables. I see that they all have an a. What power of a can I take? No more than a to the fourth, the low power. They all have b's. I can take no more than, the low one is b to the fourth. So I'm going to divide a to the fourth, b to the fourth into each of these. So it takes a minute to write that all down. Some people don't need to write it down, and I'm going to scoot this over and hope that I have enough room. Okay, for the first one, using the quotient rule, a to the 6 minus 4 is 2. b to the 8 minus 4 is 4. Minus a to the 5 minus 4 is a to the first. I'm not going to write the 1. The b's, b to the fourth over b to the fourth, those divide out. Plus sign. A to the fourth, those divide out. Use the quotient rule on the b's. B to the 7 minus 4 is b to the third. The last one, the a to the fourth divide out, the b to the fourth divide out, didn't cancel out, they divided out, and it leaves you with, not a plus, a minus 1. You could check it by distributing that to each of the 4 terms on the inside. Be sure to write it all down. Sometimes these are a real challenge to enter in to my math lab. All right, number 6 and 7 have you do something that you really do need to be aware of. You notice that in this one, the leading coefficient is a negative. We are never going to leave the leading coefficient as a negative. So if there's a common factor, we're going to force it to be a negative common factor. If there's not a common factor, but there is a negative here, we're going to take -1 out. We're never going to leave our polynomial that we're supposed to factor with a leading coefficient that's negative. All right, so I have -5x minus 10. 5 goes into both of those. Because the leading one is negative, I'm going to factor out -5. So I'm going to divide each of those by -5. It's going to cause my signs to change. Negative divided by negative is positive, and I'll just have an x. -10 divided by -5 is positive 2. So when and if the first term is negative, I don't care what all the rest of the signs are. If the first term is negative, always factor out a negative common factor. Okay, one more. I have -6 a to the 5th plus 4a to the 4th minus 2a to the 3rd. Greatest common factor. And I don't know if I wrote it or if it disappeared, but I lost that sign. There it is. And it's a very important sign because when the first term is negative, I'm going to factor out a negative something. And if I can't find anything to factor out, I'll factor out a -1. All right, but 6, 4, and 2 are all divisible by 2. They all have a's. The low power is a to the third. So I'm going to divide each of these by -2 a to the third. Negative divided by negative is positive. That's going to be positive 3. A to the 5 minus 3 is 2, quotient rule. Positive 4 divided by -2 is -2. Let's scoot this over a little. A to the 4th over a to the 3rd. Subtract the exponents for a to the implied 1 that we're not going to write. And then -2a to the 3rd divided by -2a to the 3rd. It completely divides out, leaving plus 1 because it was negative divided by negative. So if the leading term is negative, always factor out a negative common factor. One last thing, and you may not see it right now, but suppose you had -7x squared plus 14y to the 3rd. Whoops, let me change that change it to 15 to make it illustrate what I'm talking about. There is no common factor between 7 and 15. That's an x and that's a y. So there doesn't appear to be a common factor. But because of this, I would factor out -1, parentheses. It would change it to positive 7x squared and negative 15y to the third. You could write it like that, or you could just put the negative sign. So if the leading term is negative, there must be a negative common factor factored out. If there's not a shared number, like in these two, then you will just take out a -1. Okay, I hope that that is enough to do 6.1.1.